Okay, now we're going to answer questions on the assignment. Okay, number 19 on your homework assignment.
Wait, was this a new assignment you handed out yesterday?
Yes. Okay, guys, number 19, what we learned yesterday for D wasn't here. Who else wasn't here? Okay, D, what we learned yesterday is how to solve, no, it's the next one. Oh, wait, does it say complex? Might be under those.
Complex solutions?
Right there. Okay, what we learned yesterday is it's the same thing. It's using the quadratic formula, which we have been using, except for all our solutions are going to be what? Imaginary. That's right. How many of you guys remember what the square root of negative 1 equals? I. That's right. Okay. Square root of negative 1 is I. So what's going to happen is we're going to get answers like this. We're going to get square root of negative 5 in our answer. Well, the square root of negative 5 can be written as the square root of negative 1 times the square root of 5. And what is the square root of negative 1? I. So the answer is I square root 5, right? So you also might get something like this, the square root of negative 24. And so then I've got to break down 24, 6 and 4, 2 and 3, 2 and 2. There's a pair, loner, loner, right? And so that's going to break down into 2 root. I take one of the pairs and put it outside. 2 times 3 is 6. I put the loners back inside. So this breaks down into 2i square root 6 because I had a square root of a negative number right there. That's square root of negative 1, which is I. So when we did these problems yesterday, these are kind of solutions that you were supposed to be getting. Okay, so right here, we're going to solve this one. I need to know what A, B, and C are. Well, what is A, everybody? 6. What is B, everybody? And what is C? 12. Okay, we're going to solve this problem right here. Do you remember how to get A, B, and C? A, B, and C, right?
Remember what you just did a second ago? You do that first and then find it?
No, what I was just showing you. What some of our solutions might look like. That's all I was showing you. Okay. So that had nothing to do with this specific problem. Okay. Now, you guys, the first part I always like to find is the discriminant, the b squared minus 4ac part. Okay, and what is b squared? 8 squared. Minus 4 times a, which is 6, times c, which is 12. So I get 64 minus 4 times 6 times 12. Actually, just put the whole thing in your calculator. What's 8 squared minus 4 times 6 times 12? Okay, Natalie said negative 224. Anybody else get that? That's what you got? Okay, anybody else? I would put it in your calculator just so you make sure you know it's right. Okay, so now we're going to put it in the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, which is the discriminant, over 2a. Well, D, do you remember how to do this? What's negative b? Negative 8 plus or minus the square root of negative 224. That's right. All over what? Which is 12. Good. Yeah, you remember this, don't you? Now, what I was showing you before I started doing this problem is how you get answers like square root of negative 224. Okay, so we've got to break down 224. We already know it's negative. We already know we're going to have an I, right? So I know I know that 224 is at least divisible by 2 because it's an even number, right? So 2 and 112, I believe, right? I know 112 is divisible by 2 because it's an even number. How many times does 2 go into it? 56 times? And I also know, well, what's two numbers I can times together to get 56? Okay, 8 and 7, right? And I know that 8 breaks down to 2 times 4, and I know that 4 breaks down to 2 times 2, right? So let's circle all our pairs. Here's a pair of 2's. Here's a pair of 2's. Here's a 2 that doesn't have a pair to go with, and here's a 7 that doesn't have a pair to go with, right? So I take one of the pairs from that pair of 2's. I take one from that one, times it. I take the 2 loners and times them together, 2 times 7, and put them back inside the square root. So I took that 2 from that pair, that 2 from that pair, that 2 right there, and that 7 goes right there, right? So 2 times 2 is 4, 2 times 7 is 14. So I know my number, 224, is going to break down to 4 times the square root of 14. So I'm going to write x equals -8 plus or minus 4i square root of 14, because I have that I have to take in consent. 4i square root of 14. You guys, we usually always write the I before the square root, after a number if we have it. All divided by 12. Yeah, actually, there's a bigger number that goes into, yeah. 4 will go into 8, 4, and 12. By the way, don't worry about the number inside the radical, right? Because it's already simplified, and you can't divide a number outside the radical into a radical. So 4 goes into 8, 4, and 12. Well, how many times does 4 go into 8, you guys? Okay, and 4 into -8 is -2. 4 into 4 goes how many times? Once. So it's going to be I square root of 14, 1i squared root of 14. And 4 will go into 12 how many times? 3. And so here is your answer. Well, 4 into 4 is 1 time, and 1i is just an I. So you don't have to write 1i. Okay? Say that again. You got that now? You understand it? Okay. That's it. That's all you're doing on all of those problems. Okay? How many of you are done with this assignment? Excellent. Okay. Okay. I'm going to give you actually a little time to work on this today, but I have a small 8-problem assignment for you to do today as well. So I'm going to discuss that. And I'm going to do that first, and then you guys can work on both assignments, because some of you guys are done with this assignment. Some of you guys are still working on it. We're going to grade this assignment towards the end of class. Okay? The quadratic one. Is there one more you guys would like me to do? We only did the odds.
What about 6?
Number 6. 6 is an even. You don't need to do it. And did we do 6 yesterday? Okay, I'll do 13. I think I did 13 yesterday, but oh, I did an even on like 13. Okay. All right, Gabe. What's A, B, and C? What's A, Gabe? No, X. Gabe, A is the coefficient of x squared. Do you see a coefficient of x squared? Coefficient. There's no coefficient there. That means it's 1. What's B?
Anthony.
And what's C? 97 over 6. Okay. We're going to figure out the determinant, the discriminant first. B squared minus 4AC. Okay. What are we going to put in for B? Gabe, what are we going to put in for B here? 8 times 4 times A, which is 1, which I'm not going to put, times C, which is 97 over 6. What'd you say?
Negative 0.6666.
Yeah. Yesterday I taught these guys, because most of them didn't know this.
You put a dash on top of it.
Yeah. What is 6 repeating, everybody? 2/3. I taught these guys. What's negative 2/3? Go negative 2 divided by 3 in your calculator. Because it's easier to work with the fraction.
But how do I know?
Go negative 2 divided by 3. Same answer, right?
What is that?
But it's a fraction instead of a decimal?
Is that because 2 times 6?
No, 2 divided by 3 is 0.6 repeating.
How would you figure that? How would you possibly?
Well, do you remember long division? 3 into 2?
Yeah.
3 won't go into 2, but 3 will go into 20 6 times, right? And our decimal's right there. So I put 6. 6 times 3 is 18. Well, my remainder is 2. 3 won't go into 2, so you bring down another 0. 3 will go into 20 6 times. 6 times 3 is 18. Okay, bring down 2. Bring down a 0. 3 will go into 26 times. How long is that going to last for?
For a while.
For a long time, right? That's 2/3. Okay?
Wait, what does the 7 come from?
It's 97 over 6. Oh, because the very last one they round up in their calculator. All right. Okay, now, x equals. Okay? Okay, Nicole, what's right here on my quadratic formula, what am I going to do? X equals what? Negative 8 plus or minus. Okay, if I write it with an I instead of a negative, what would I write? I out front over 2/3, okay? All over 2. 2 times 1 is 2. And I told you guys you can leave the answer like that. Technically, the square root of 2/3 can be written as the square root of 2 over the square root of 3. And mathematicians don't like square roots in the bottom, so they usually would do what they call rationalize it. But I'm not going to do that right now. We're going to leave it like that. Okay, Lacey. How did I get what? Negative 8. Because in the quadratic formula that says negative b plus or minus the square root of b squared minus 4ac over 2a, I was making a substitution for b, and it says negative b. So the opposite, or the negative of 8 is negative 8. You always take the opposite of whatever b is. Okay, any other questions? Okay. All right, I am going to move on to something else right now. And then this is what we're going to do. I'm going to give you guys about 15, 20 minutes to finish this assignment up. Then after you finish this assignment, we're going to correct it. But you'll also have the other one to work on in the meantime, okay? So, this is what we're going to do. We're going to talk about the 5 ways to solve a quadratic equation. Well, I briefly talked about it, but I want to make sure you guys know all the ways. Okay, number 1 way, graphing. And I would suggest you take notes on this. Okay, our next test is coming up really soon. And if you write this down on your card, that will help you out. Because then you'll look at a problem and say, oh yeah, there's this way, this way, this way, this way, or this way. Okay? So graphing is one way. Now, you guys, what is the problem with graphing? There's 2 main problems with solving by graphing. Okay, one of the problems, someone said, is it's not always exact. That is precisely one of the reasons. Because sometimes it's going to cross the x-axis between 2 integers, like 5 and 6. So it's 5 point something, but it's kind of hard to tell exactly what it is. So that's one problem. What's another problem? Okay, the other problem is this right here. I'll draw a picture of it. What's the problem with that, you guys? What? It doesn't cross the x-axis because what kind of solutions does it have? It has imaginary solutions. Imaginary solutions can only be found. Okay. Let me just review it one more time. Imaginary solutions can be found algebraically using the quadratic formula or completing the square, but they can't be found by graphing, okay? So graphing, hey, someone mentioned at the first class, graphing is a great way to do it, and you're right. Graphing is a great way to do it if it crosses through integers, and it's close enough to 0, 0 that when you graph it, you can see it, okay? So sometimes this is a great way to do it, sometimes not. Okay, the second way is by taking the square root. I don't remember if I talked about this in this class. I've talked about it in my honors classes. But I can't remember if I talked about it in here. Have I talked about it? Okay, the problem with this one, it only works if there is no linear term. Okay? This one only works if there's no linear term. For example, let's say I had something like x squared minus 25 equals 0. Say I had something like that. This is actually the easiest ones to solve when there's no linear equations. Dean, what do you think I can do to get x by itself right here? Okay, I can add 25 to both sides, right? I can add 25 to both sides. Then what can I do to get x by itself? I can take the square root of both sides. Because what happens when I take the square root of x squared? I get x. And over here, I get plus or minus. Remember, whenever you take the square root of x squared, you get plus or minus on the other side. Plus or minus the square root of 25. What's the square root of 25? 5. So there's my two answers, positive 5 and negative 5 in that case. That's kind of an easy way to do it, isn't it? Do you guys understand when I say there's no linear term here? X squared is here, but there's no something x, right? Okay? And then there's a constant. So it only works when there's a quadratic term and a constant term. Let's look at another way. Let's say I have something like 9x squared minus 49 equals 0. Let's look at that one. Okay? Lexi, what could I do to get x by itself right here? Okay, add 49 to both sides. So 9x squared equals 49. Get rid of the 49 on the left side. Okay, Monica, what can I do next to get x squared by itself? To get x by itself. How do I get rid of this 9? Yep, divide by 9. Okay, 9's cancel out, and I get x squared equals 49 over 9. Okay, what's the last thing I can do to get x by itself? Because I have x squared equals 49 over 9. Square root. And if I do that, I get x equals plus or minus the square root of 49 over the square root of 9. Well, guess what? Those are both perfect squares, so we're going to be able to simplify this. And what is the square root? Savannah, what's the square root of 49? Yep. And what's the square root of 9? And so my answer is plus or minus 7/3. Okay? On that one. Let me show you another one. I got to show you two more. X squared minus... Huh? Oh, yeah. Did you guys hear that? That's a good question. If I would have done this by graphing or by the quadratic formula, I would have got the same answer. Or by factoring. Same with this one. If I did it by any of those other methods, I would have got 7/3 and -7/3. All these, this one right here, you can do in any of the ways. You can do it all 5 ways that I showed you. Okay, what about this one right here? What could I do to solve this one? Add 5 to both sides. So I'm going to get x squared equals the square root of 5. Or no, of 5. X squared equals 5 because I'm going to add 5 to both sides. Then what can I do to both sides? Okay, I can take the square root of both sides, and I get x equals plus or minus what? The square root of 5. Since 5 doesn't break down, it's not simplifiable, I don't want it as a decimal. So that's my answer. Plus or minus the square root of 5. One last one like this. X squared plus 10 equals 0. X squared plus 10. What can I do right here, Austin? What can I do right here to get x by itself? I got to get rid of this plus 10. How do I get rid of that? Minus 10. And I get x squared equals -10. And then I take the square root of both sides. And I get x equals I square root of 10, right? Plus or minus I square root of 10. Do you guys understand how I got I square root of 10? Because I was taking the square root of a negative number, so it's I. 10 doesn't simplify, so it's I square root 10. We got that? Okay, now, I got to go back to the top of this. We did 2 ways, graphing and taking the square root. You guys ready for the third way? We'll get a new thing for the third way. The third way is by factoring. Let me remind you of one that we can do by factoring. How about x squared plus 3x minus 40 equals 0? By the way, could I do this one using the quadratic formula? Yeah, I can do all of them, Gabe. And Cal, did you guys know I can do all of these by using the quadratic formula? Okay, but I'm going to do this one by factoring because it's factorable. You guys, are there 2 numbers I can times together and get -40 and add together and get 3? What's 2 numbers you can think of that you can times together and get 40? 4 times 10 is 40. Is the difference between 4 and 8 and 5? 8 times 5 is 40. Is the difference between 8 and 5 3? Yeah. So it would actually be +8 and x plus 8 and x minus 5. Because look, 8 times a -5 is a -40, and 8 plus -5 is a +3, right? And then, what are my answers going to be? No, remember I said each factor equal to 0. So I -8 from both sides of this, and I get -8. Add 5 to both sides of this one, so I get +5. Got it? So there's my answer, -8 and 5. I could have done this one by using the quadratic formula, but it's faster to factor it if you know how to factor it. But if you guys are struggling with factoring, guess what? Do it this way. Okay? Got it? I mean, do it. If you're struggling factoring, doing it this way, which is easy, you can use the quadratic formula. Well, you know what? If it's a really hard problem, let's say I gave you something like this. Okay? Let's say I gave you something like 2x squared plus 18x plus 28 equals 0. You guys, let's say I give you something like this. This one's actually factorable. The problem is, that's 1 times 2 there. I have 1 and 28, 2 and 14, 4 and 7. Those are my possibilities there. I can see right now that 2 times 7 is 14, and 1 times 4 is 4. And 14 plus 4 add up to 18, which is my middle term. So I can factor this one to be 2x and x That's where this is 1x, and that's 2x right there. And I know 7 goes opposite of 2, so here's 2, so 7 is going to go over here, and 4 is going to go right there. And then I can set each factor equal to 0 here. And I can minus 4 from this one, and then divide by 2 to get negative 4 divided by 2 is negative 2. There's one of my answers. And over here, I can minus 7 to get negative 7. And there's an answer right there. So those are my 2 answers. That's easy for me to do by factoring, but if it's not easy for you to do by factoring, use what? You can either do graphing or completing the square, which we didn't really go over completing the square much, or the quadratic formula. You can use the quadratic formula on this. Huh? Yep, 2 more ways. Okay, after factoring, because after factoring, number 4 is completing the square. But guess what? Completing the square to solve a quadratic equation is a long, tedious, slow way. I never use that way. But remember when we learned completing the square, I showed you guys how to complete the square to get the quadratic formula? So the 5th way, which you guys should use, is the quadratic formula, which we have been using the last several days, and you should know how to do it. You can do everybody write this down, any quadratic can be solved with this. Okay? Guys, the quadratic formula, any quadratic equation can be solved with the quadratic formula. Any of them. Even on that first one where we did taking the square root of both sides, the linear term was 0. You could put 0 in for b. Got it? So any single problem can be done this method right here. All right, now I have got a short assignment for you, 8 problems. And this is what we're going to do. I've kind of already mentioned it. We are going to correct we're going to correct this one that says quadratics with complex solutions, the one I answered questions on at first of class. We're going to correct that in about 20 minutes. About 20 minutes. I'll give you 25 minutes. How's that sound? If you are done with that, I would be working on this. Today's assignment's only 8 problems. No extra credit on this one. But by getting good scores, you can always improve your grade. I got to turn this off.